everyone, and welcome to this video on work and power. In this video, we're going to discuss what work is, the concept of work and energy and how they relate to one another, and the concept of power. So first off, what is work? Well, work and energy, which we talked about in another video, are very similar to one another. Energy makes things happen, while work is noting how much energy is required to do a certain job. So, for example, if this man is pushing a boulder up a mountain, it's going to take a certain amount of energy to make this happen. The energy required is the work. Similarly, if this man pushes a boulder along the flat, it's going to take some energy to do that as well. And the energy required to do this task is the work. The definition of work is how much energy is needed to get a job done. Now, work is symbolized by this W. So if you see a W in the physics equations, it's talking about work. The unit is joules, and this is exactly the same as for energy. And finally, just a reminder that 1 kilojoule, or the small k with the big J, is equal to 1,000 joules, just in case you ever see this in your questions. Unlike most of the things we've learned, there are two formulas for work, and one of them involves force, and the other involves energy. So starting with the one that involves force, work is equal to force times distance. So if we have this man pushing the crate, he's pushed it with a certain force for a certain distance. And if we multiply the force he's put in to the distance, we get the amount of work that has been done. And this can be simplified into W equals F times D. It means exactly the same thing. The other way of measuring it is with energy, where work is equal to the energy required, which makes sense because that was the definition we just talked about. It's W, or work, equals delta E. And remember, this delta just means change in. So it's simply saying the amount of energy required to do a job is the same as the work. So if we had the man pushing the exact same crate a certain distance, the energy required to do it would be the work. And don't get confused, both of these formulas will give you the exact same answer. So in an exam, they might ask us something like this. A man's pushing a box up a ramp. Another man is lifting a box. Explain which of the actions requires more work, and ignore friction. So what they're saying here is this person is pushing the box up the ramp. This person has just lifted the box straight to the top of the ramp. Well, the first thing to note is that both are doing the exact same action, which is getting the box from ground level all the way to the top of the ramp. Because we know that work is the energy required to get a job done, and they're doing the exact same job in different ways, we know that the same amount of work has been done. So it doesn't matter how they do the job, whether they push the box all the way up the ramp, or whether they just lift the box up, they're doing the same thing in the end, so it's going to take the same amount of work. And if you understand that work is just the energy required to do something, this will make sense. They may also ask you to use work in a calculation. So they might say the ramp is 2 meters long and the man is pushing the box with 200 newtons of force. Calculate the work done. So in this case, we're just dealing with the box being pushed up the ramp. And we've got two formulas we could use to answer this question. Work equals change in energy, and work equals force times distance. And to know which one to use, we need to look at what they've given us in the question. The ramp is 2 meters long. We've got 2 meters long, which is a distance. And the man is pushing the box with 200 newtons of force. Well, the 200 newtons of force is talking about force. By doing this, we quickly realize that the second equation is the one we want to use. So I've written the shorthand for this equation, work equals force times distance, and I'm just going to put the numbers in where the letters were. So I've put in the 2 for the distance and the 200 for the force. Put this into my calculator, and I get that the work done by the man is 400 joules. They could ask you a different style of calculate question as well. And this time we're dealing with the man lifting the box, and he's lifting it to a height of 1 meter off the ground. The box weighs 40 kgs, and they want us to calculate the work done. So the same thing as before for the other person. So to do this, we first need to work out what's happening, which is this man lifting the box up to the top of the ramp. We know that we have our two formulas, work equals change in energy, and work equals force times distance. And we need to know which one to use. Well, going along this question, we can see that we've got a height of 1 meter off the ground, so we've got height, and we've got a mass of 40 kgs here. However, we don't have a force, and we don't have a distance either, so it wouldn't be appropriate to use this second equation. So what we're going to use is this top one, work equals change in energy. And the type of energy that we're talking about here is the energy of height, or gravitational potential energy, which we talked about in another video. We know that we need to use our gravitational potential energy because we've been given a height, and gravitational potential energy is the energy of height. So this formula, EP equals mgh from another video, we simply want to work out what we have. Well, we've got a height of 1 meter, so we can fill in h. We also have a mass of 40 kilograms, so we can fill in m. And we need to work out g. We know on Earth that g is always equal to 10 meters per second, and so we have that now. And then we just put in the numbers where the letters were. So we have EP, or gravitational potential energy, equals 40, which is our mass, times 10, which is our gravity, times 1, our height. And we work out that the potential energy is 400 joules. Why this is important is because work is equal to the change in energy. And so this means the work is also 400 joules. The next thing we're going to learn about is power. And to explain power, we're going to have these two people pushing these boulders. We'll watch the first person push the boulder. You can see that's happening very slowly. We'll watch the second person push the boulder, and that one happened really quickly. Now they've done the same amount of work because we just learned that the work is the amount of energy required to do a job, and they just did the same job. They both pushed the boulder the same distance. Power talks about how fast work is being done. So while the work of these two people is the same, the power will be completely different because one person did the job really quickly, or the other person took forever to do the job. So how is power measured? Well, the symbol for power is the letter P. And the unit for power is watts, which can be summarized as this W here. So don't get confused between the W in physics equations, which is work, and the W as a unit, which is watts. And power is related to work and time. And it's related with this formula here. Power equals work divided by time. So it's how much work you did, but it's also how fast you did that work. And to put it into shorthand, you'll see it in your exam like this. P equals W divided by T. So if this person was to push the boulder, we're looking at how much work was done, but we're also looking at how long it took to do that work. And this is the measure for power. So let's look at the same explain question we did for work, except we're putting power in its place. So again, just as a reminder, the man's pushing a box up the ramp, another man is lifting the box. We're going to explain this time which action requires more power. So remember from doing this earlier that they're both doing the exact same action, and that's getting the box to the top of the ramp. They're just doing it in two different ways. And we know that if somebody's doing the same job, it's going to take the same amount of energy or the same work. However, power is about how fast the work was done, not just what work was done. And so we could say here that's quite likely that this person here lifting the box would have done it faster than this person pushing the box all the way up the ramp. And because of this, the power of this person here lifting the box will be higher than the power of the person pushing it all the way up the ramp. So let's look at a calculate question for this now. So this time we're looking at the man pushing the box up the ramp. It takes him 10 seconds to do it, and the amount of work that it took was 400 joules, which we worked out earlier. So this time we're calculating the power generated by this man. We know that power is equal to work over time, or P equals W over T. The next thing we do is go through the question and find information that we need. And so the work done to push the box up the ramp is 400 joules, and so we've got a work of 400 joules. It takes the man 10 seconds to do this, and 10 seconds is a time. So we've got work and we've got time, meaning we can determine power. We then put our numbers in where the letters are. So we put in P equals 400, which is the work, divided by 10, which is the time, and we get a power of 40 watts. And remember to put watts in so you get the question correct. And so in summary, what do you need to know? Well, you need to know work is the energy required to get a job done. And there are two formulas for work. One is work equals force times distance, and that's W equals F times D. And one involves energy, where work is equal to the energy required. So W equals delta E. And remember, this delta just means change in. And the other thing that we need to know is power. And power is how fast work is getting done. So power is equal to work divided by time. And if you forget this, just remember the situation with the two people pushing these boulders. The key facts about power: the symbol is P, the unit is watts, and it's related to work and time. Thanks for watching this video, guys, and I'll see you in a different one.